So what to understand from each type of distribution? And so when we look at a uniform distribution, I think one of the common ones that you probably like the most is where we see right here a value is occurring one time, occurs over completely across the data set. This usually means it's something like an index. It is not likely going to be usable if it only occurs once throughout the whole data set. There's nothing to be learned. There's no pattern there. There's no reoccurring pattern that can be understood. And so really this likely is a data set that or this column, this feature, it is not going to be useful in our data analysis. It's important to understand and just kind of eliminate that. We might need it to access data at certain points to find out where the data is if it's an ID column, but in our analysis, it's not so important. So we can kind of just save that for later, so to speak. Another thing that will commonly happen is you'll see these kind of abnormal types of distributions where we have two levels. It doesn't necessarily just need to be a uniform distribution, but here you see these two levels essentially with this. And so when that happens, you can see your data analyst gentleman here, he's thinking pretty hard. And you don't want to, hurt yourself thinking too hard, right? So we see that there are two different levels in this distribution, and really that's the time that we want to talk to the expert. We can get really far with what Python can do, but at a certain point, you need to rely on your business partner. Why am I seeing this? This is an insurance premium. Likely could be related to some levels. The pricing system would make sense. Maybe age, and once you cross an age range, it just drops or it just increases. And that could be why we're seeing this distinct level in these distributions, on this uniform distribution. What to understand from a normal distribution? I think the biggest thing is that we look for is outliers. It really, is there long, really even tails, I guess that sense. Is there something that's pulling the mean to one direction or the other direction? This affects so many things. So we really want to pay attention to how the outliers could be affecting our summary statistics, because that will can affect something simple like a mean. It can affect the correlation. It can affect our machine learning models. So if you're doing a data analysis to support a machine learning engineer, much more important to understand the outliers and really focus on these. It always surprised me the effect they have, but it really does have a large effect. We can also use normal distribution as you can see here, we have kind of an abnormal distribution. I would say this is, to me, if we had more data, it might start to fill or become closer to a normal distribution. It might not though, right? So we can say this is a semi-normal distribution. Falls somewhat the normal. It's a quick way to really visualize semi-normal. Okay, so it's kind of roughly the shape of a normal, but I'm not going to expect it to be exactly, and that kind of fits this in. There isn't really a good way to describe something that's kind of funky looking like this. There's a specific name is a very unique distribution, but again, relating it to the closest proximity that we have for that distribution. So looking at our little outlier friend here, we always want to keep an idea like this outlier friend here. He's pulling the mountain, he's pulling the moon towards him. Kind of extreme, but outliers do have a really surprisingly large effect on our summary statistics and kind of everything up from there. So we really have to pay attention to them. I did not want to believe that when I started. It is data, but we don't want them to skew our analysis, and that's the problem. They do kind of our summary statistics adapt to the outlier versus the bulk of our data, and that's not really what we want to understand. We want to understand the majority of our data, not just the outlier situation. Outlier situation is maybe something we save, we compartmentalize and study by itself, or we do things to manage its effect on the distribution.